So we'll wait for a few more seconds for everyone to come in, settle, and then we'll start. So I see we have 44 participants. I think it's 2 minutes after 3 on my clock. This is the time to start. So welcome back. Welcome everyone. I appreciate you all taking time out for this webinar. This is a joint webinar from AEESP Education Committee and SOS Giants Community of Practice. We have a fabulous panel here, and I'm proud to introduce them to you all, even though they don't need any kind of introduction, but I will try my best. Myself, my name is Sanjay Tiwari. I am the committee chair of AEESP Education Committee. I recently took that charge, and this is one of the first activities that I got to do. A little bit my background. I am currently with Missouri S&T, and before that, I was with Louisiana Tech University. Now, moving on to our panel, we have 4 fabulous pioneers that have been active in the field of environmental engineering as educator as well as researcher for a long time. I was just trying to do the math, and I noticed that it's over 150 years of combined experience and wisdom among 4 of them. And I'm not going to even add citations and everything and the textbooks this panel has published. So before I introduce them to you, I have my colleagues from Education Committee who are helping me, Tae-Young Kim from Clarkson University and Stephanie Lofton from the Citadel. They will be helping me with the webinar, and they have been instrumental in planning and everything with me. So my introduction is going to be in order. They are going to present Dr. James Malik. He is affiliated with Department of Civil and Environment Engineering at University of South Florida, and he has more than 30 years of academic experience plus 45 years of professional experience in environment engineering. Has published multiple textbooks. His research has been cited by thousands of the researchers from all over the world. So that's the theme you probably will see. I will repeat this line multiple times. They have published many books, and their research has been cited by thousands of the people. We have Dr. Bruce Rittman. He is currently a Regents Professor and the Director of Biodesign Center for Environmental Biotechnology at Arizona State University. And he has 46 years of academic experience, taught multiple courses. His work has been cited by more than 71,000 times across the world, and his iTag index is 665 on Google Scholar. Dr. Sue Meston recently retired from Michigan State University after 36 years in academia. She has taught multiple undergrad and graduate environmental courses, has published many textbooks. And I'm proud to say that a couple of my classes are following one of her textbook. So, uh, uh, and again, her work has been cited by thousands of researchers. Uh, Dr. Susan Powers, she is at Clarkson University and has been there uh, for 34 years. And she is currently serving as a director of the Institute for Sustainable Environment, a center over there. And she has taught multiple courses and has been a productive researcher, thousands of citations. And her focus in classes has been uh, on project-based learning. Uh, with that, I invite Dr. Malik to uh, start the discussion, tell us more about him and his philosophy, and what has made and shaped his experience when it comes to teaching in classes.
Thank you, Sanjay, and good afternoon to everybody. And I'd just start off by stating my first service with AEESP was with the Education Committee. So good job to them. Okay, so many of you know me from my research. Many also know me from my educational initiatives. And I show on this slide many of the books that you might be familiar with. And if you use my John Wiley environmental engineering textbook, I'm in the planning stages of a fourth edition. I'd love to hear suggestions any people in the audience might have to improve it as an instructional resource. So just track me down and email me your thoughts, or we could talk on the phone. So some ask how I got to be known as an educational pioneer, and I would say I really don't know how I got into this. Like the other panel speakers, I always had extensive and impactful research portfolio. I wrote my first book, which is up there in the upper left, the Environmental Engineering Fundamentals book. And it was really because we were at the time teaching a class to environmental undergrads, which was different than maybe the first class for civils. And we just didn't have a book. So I wrote it, and I wrote it with some colleagues. And important, I never felt like book writing took away from my research and associated scholarship. And really, if you think about the impact of a good book, my environmental engineering textbook has sold in the tens of thousands of copies, my top research papers, have in the thousands of citations. So that's a tenfold increase. So you can have a big impact doing something impactful at the education level. Now, I'd also like you to think about how you can work on an educational impact in educational initiative that not only impacts students but maybe impacts practitioners. So, for example, my ASCE field engineering book, about how you do environmental engineering in a developing world context, and I'm working on this current UNESCO project on the fate of different pathogens in different on-site and centralized sanitation systems. And the audience there are not only students, but it's primarily for practitioners that work for government or non-government organizations, maybe a consulting firm. And so this could have a really big impact as well as educating students. And this allowed me even to have a book forward written by former President Jimmy Carter. So who can say that? That's pretty exciting for me. Now, my philosophy is I would always say, I play ice hockey or used to, and I was always someone who wanted to skate to where the puck was going to be. I didn't want to skate to where the puck was already at. So I was always thinking about future. And my book reflects this in some of my personal values. So I understand we have to teach our students about mass and energy balances, kinetics, how to model the fate and transport of pollutants in air, how to design an activated sludge system. But you can see in my books, my expectation that engineering students incorporate sustainability into their problem solving. They consider issues of inequity and injustice when in considering environmental risk. They think of not only how their decisions impact local communities, but the world. And they get an appreciation of history that led to this career. They understand environmental laws that were passed well before that they were born. They can see solutions as not just technological, but maybe there's policy-derived solutions. And I always work in current local and global events into the beginning of the class, which I think is important to engage with students. Now, I have another suggestion. I've always engaged my graduate students and especially PhD students with me on educational products and educational research. It's been very, very fulfilling for me. If you have graduate students, I encourage you to engage them in something you're doing innovative in the classroom or out of the classroom. Just make sure it's something that does not take away from their research or coursework. It's integrated with their professional goals. Encourage them to disseminate this new knowledge that they create. They can publish in peer-reviewed conference proceedings with ASEE, and there's a lot of excellent peer-reviewed educational journal publications. So I just want to finish now, just share a few hints on balancing your teaching and your service in research and your personal life. So I've always been very protective of my free time outside of the university. So I had one senior professor that told me when I was a junior faculty that time was finite, and I think that's really true. And so what I really mean here is I don't want to spend all of my university holiday or semester break grading exams or projects, right? This is time for personal or devoting to research. And so I would thus encourage people, if you aren't already, space out your course deliverables throughout the semester, not load everything up at the end or before a break. It's important that you are engaged in assessing deliverables by students, right? And you can see how you're doing or provide inputs on how better students can learn. I rarely give a long backbreaking final exam if I already have a nice spread of class grades from previous work. In that case, I'll use a final exam that's a little shorter. It's really for me to determine who really deserves a D or an F. And perhaps there's students that, they had a bad day on exam 2. And, overall they're performing well in class and they just need to prove that to me on a final. I've learned individual students learn differently. I think we all know this. So some learn well outside of the classroom. Others learn from case studies. Some require a nudge to complete assignments. And I'm always trying to think how to get people to open up the books, right? Some students read the book and a lot don't. And I think we could all do better if we get everybody to open up the book or open up other resources. So that's it. Please contact me if you want to talk about environmental engineering, education. And now I'll just turn it on to the next speaker. I'm looking forward to hearing what they have to say.
Okay, and that next speaker is me, Bruce Rittman. And you can see here a few pieces of information about me. I started my career at the University of Illinois in Urbana-Champaign. I was there for about 12 and a half years. I then moved to Northwestern University, and I had the role of being the leader of the environmental engineering program, which was a great opportunity for me. And then in 2005, I moved to Arizona State University, where I had the incredible opportunity to start a research center, the Biodesign Sweetie Center for Environmental Biotechnology. I took the opportunity. By the way, my background, you can see behind my head, is the Biodesign Institute. That's my background for today. Okay, let's go to the next one. Okay, so I've been teaching here for 46 years. And for those 46 years, I've only taught 8 courses. And listen to them here. I'm not going to read them. You can see the first one is your basic sophomore, junior level introduction to environmental engineering for, mainly civil environmental engineers. And then the last one is an advanced environmental biotechnology course. Almost exclusively PhD students take that. So it's really quite a range. But the key here is that I didn't taught too many courses. And why is that good? Well, it's good because I got to be really efficient at all of them. I mean, I really understand the material. I have my course materials ready to go, and I didn't spend a lot of time getting up to speed over and over again. So my advice to everyone, especially the younger faculty members, is to try to teach only a few courses. Don't keep changing courses. Stick with a few courses. Get really good at teaching those courses. You'll be efficient, you'll be a better instructor for it, and you want to make sure that you really are expert, whether you're expert going in or it takes a little while to become an expert. You really want to be an expert at the course you're teaching, and you'll do a better job for the students and you'll do a better job for yourself. Okay, next. Okay, now, from my experience, teaching undergraduate courses is very different from teaching graduate courses. So here are some of my uh, thoughts about undergraduate courses. So bullet number one, I'm always 100% organized before the semester begins. I always have everything done, all readings, PowerPoints, handouts, homework assignments, everything 100% done before the semester starts. I don't want to leave anything to chance, and I don't want to make myself crazy during the middle of the semester trying to play catch up. So I always make sure everything is in place before I start. Now, there's some flexibility, things shift around a little bit, but if you get it done in advance, then it's just little shifts. It's not so bad. Point number two, I'm always giving the students feedback, grading their homeworks, grading their exams. I do it right away. They need the feedback. If they're on track, wonderful. If they're not on track, they need to know they're not on track so they can get themselves back on track. And I provide a lot of written comments as well as or oral comments if they come and visit me after class or at office hours or making a special appointment. Now, one thing I've been doing more so recently is taking attendance, actually passing around an attendance sheet in every class. Because, every faculty member I talk to complains about students not showing up. And that's really a terrible thing because what we cover in class is really the most important stuff. So they need to show up, and I'm going to let them know that I think they should be showing up. And so I make sure I take attendance, and they know I'm taking attendance, and they know that's going to play a part in their grade. Uh, I set up meetings as necessary with students who have questions. That's actually a lot of fun. And the last point here is I am not an easy grader. Do not have a reputation of giving an easy A. Everybody knows if they get an A from me, they really earned it. And of course, if they got something else, they earned that one too. So my advice, make sure that the students understand that you have high standards. These are all professional courses. All of these students are going to go on and make this part of their careers, and they need to behave now and act now like professionals. And that's something I emphasize including, in the way I teach the course and the way I grade the course. Okay, next. Now, graduate courses, it's a little bit different. The students are generally more motivated. They usually show up all the time on it. But for me, again, I'm always 100% organized before the semester begins. I never leave anything to chance. Everything is prepared. I remember the first graduate course I ever taught. This was in 1980. I brand new professor at the University of Illinois. And I came in to teach a class. And of course, then it was before we had computers, laptop computers, and all that stuff. So I prepared this packet, pretty thick packet of course materials, and I dropped one on the table and impressed the students in the right way. And so I do that, for every semester because I don't want to get behind and be in a panic, and I want the students to know what's expected of them. Now, in a graduate course, I give the students a lot more responsibility for learning, active learning here. And I'll give an example of my advanced environmental biotechnology course. Now, this course, I do not give any lectures, zero, absolutely zero lectures. I give the students a study guide, I give them lots of readings, and they're supposed to come to prepared to class. And then I say, Joe, go up to the board and explain this concept to the class. Sarah, go up there and embellish on that. And so this is really fun. And after a few class meetings, the students get in the hang of it and they know that they're expected to do this and they prepare for the class and they actually like it, or most of them like it. And then the final thing is I expect to learn something every time I teach a graduate class. I'm going to learn it from the students. I'm just going to learn it from the interactions with the students, and I'm going to grow. So my advice, make graduate courses a learning experience for you and the students. Of course, help them to understand that they're going to become my teachers. Because if they're PhD students, that's their job, is to be teachers. They might as well start off by helping to teach me in my class. Next one. And this is the last slide I have here. And these are just some examples from a recent class in my advanced environmental biotechnology of class project topics. And I pick things that I'm interested in. I would really like to know quantitatively the difference between how membrane bioreactors work versus conventional activated sludge. And I'm really interested in the kinetics and stoichiometry for Animox and Comomox. This is really hot, current stuff. And I would like to know more about it. So I have the students do a project, class project, and make a written paper and an oral presentation on it. And we're all going to learn together on this. So they apply the concepts and techniques from the course. They learn something, I learned something, and in a few cases, we have even published papers or written proposals based on these class projects. So I'm getting a double benefit here of it. And not only am I, learning something, but I'm actually using this to advance my career on the research side. And with that, I'm going to pass it along to the next person who is Susan Maston. Susan.
Well, good afternoon. So I'm Susan Maston. I have been teaching since 1987. Yeah. So I first started at SUNY Buffalo and then spent most of my career at Michigan State. And it was also for 3 years, I was on leave from Michigan State, and I was the director of the first year engineering program at McMaster University, which gave me an opportunity to really get much more involved in undergraduate education from much more of a systemic perspective. So in terms of courses, I've done a lot of courses. Bruce mentioned, just being able to teach a few courses. A lot of it really is going to depend on where you are, situation you're in. Second year I was at Michigan State. The 2 senior faculty members in the department both went off on leave, left. It was actually Craig Criddle and I and Simon Davies. Well, in our second year, we had the program. So we taught the graduate courses, we taught the undergraduate courses, we taught whatever needed to be taught. So it's somewhat, situation you're in. And I've taught everything from just the regular environmental courses to the capstone in civil and environmental engineering, which I actually really enjoyed teaching. Gave me an opportunity to learn about civil engineering. My undergraduate degree was biochemistry. So I didn't have a civil engineering degree. So I learned a little bit about transportation, a little bit about structures, a little bit of geotech, at least enough to communicate. So it was actually really beneficial. So, my advice is take advantage of those opportunities. They're an opportunity to get to know colleagues. They're an opportunity to learn. I've learned in every course, like Bruce was saying, whether it was an undergrad course or a graduate course. I believe I've learned in each of those courses. Like Jim, I've taught, actually Bruce too. I have a number of textbooks. I actually got involved. Mac Davis asked me to write Principles of Environmental Engineering and Science with him back, I don't know, probably about 40 years ago. That was our first edition. We've just published 2 years ago, I guess now, what is now the 5th edition. It's kind of cool because it's been translated into Chinese and Spanish. None of my papers have been translated, so it's kind of cool to have a textbook that's been translated. And then I'm currently working, and that's actually not just a prototype of the mock-up of the textbook. I'm working with Belinda Sturm on water and wastewater engineering, and that's again Mac Davis's book. Those of you that may have known Mac, he passed away in July. So we're working on building on his legacy and hopefully updating that book. So kind of just some general advice on, and it builds on what was said before. Be deliberate with your time. You can't do it all, and you need time to think. One of my favorite aspects of COVID was actually be having more time to just think. I could go out for walks. I designed experiments when I was out for walks. It just gave me time to step away and think about what I was going to do next. Set clear boundaries. And this is important. There's a big difference from when most of us first taught. We didn't have email. When I first started, email was rare. You went home at night and you went home at night. You didn't answer emails. You didn't worry about, we wouldn't have done a Zoom meeting. But because of that, there's less clear boundaries between home and work. So make sure you set those clear boundaries. When do you respond to emails? When you do not? Make space, time to disconnect, rest, and renew. During COVID, I actually did reflections with students because I felt that they were at their computer screens all the time. Things like telling them to open their windows and listen, or go outside and listen to the sights and sounds and the smells of spring. And then they have to write something. And if they didn't want to write anything, they could just tell me what they had for dinner or whatever. But they had to at least respond. And it was a way of me connecting with them. But it was also a way of helping them to disconnect and just rest and renew. Whatever you do, cultivate passion in both your work, outside of it, and those that you interact with. Next slide. Most of my teaching actually in the last 20 years has been predominantly undergraduate courses, but start with a detailed syllabus, start with a course outline. If you can get everything done beforehand, great. I've never been able to. I end up changing lectures. I change homework assignments. Life happens. Everything from, one semester my dad passed away and having to take time off. Another semester when we had the shooting on campus and we all lost a week of camp classes because of it. Adjust, expect things to happen, and you just move forward, and you help students move forward too. I used minute papers in in-class group work extensively, or I did, throughout the semester. I found it was really useful to gauge understanding. I would have students start a problem. A lot of times, really all I wanted them to do was to try and set up the problem. Draw me a picture. What's happening? What's the situation? What's the mass balance that you're dealing with? And then I could also use that. I could use their understanding or their lack of understanding to adjust the next lecture. So I collected those. It did help monitor engagement and attendance, but it also helped them think about the process rather than just the answer. Initially, they were real focused. I've got to have the right answer. And I'm like, I don't care whether you get the right answer. I want to see that you're putting something down on paper, that you're just thinking. I've also used rubrics to communicate the expectations. It really helps students. I want them to work through a problem. I'm less concerned with that final answer, but it helps them it gives them a roadmap, I guess, more than anything, on how to get to where I want them to be. Next slide. The last thing I'm going to really think of, is model the behavior that you seek. If you want students to be intellectually humble, admit what you don't know and help them find out. I don't have all the answers. I never will have all the answers. I wish I did, but I don't. And it's okay to say you don't know. And it's okay to say, I'll find out, or let's find out together. Demonstrate respectful, evidence-based scientific debate. I've done debates in class and helping them understand that there is a disagreement on some issues. How do you address those? And how do you look at the evidence? And how do you think through a problem? Think about ethical decision making. I always told students that if they couldn't tell me which the first canon of the ASCE Code of Ethics, by the time they graduated, I was taking their degree back. It's make public health and safety paramount and welfare. Be curious. Teach them to be curious. If you're curious, they'll be curious. Ask real questions, be generally interested, and then balance. Show them that we are all whole human beings, learning to recognize that, okay, and balance their lives accordingly. Next slide. And final, make things relevant, connect theory to practice and learning to real world impact. Students want to make an impact. They'll probably forget the equations, they'll probably forget the lectures, but they won't forget how you made them think. They won't forget when you've helped them become the person, the engineer that they want to be. So thank you, and I'll pass this on to Sue.
Thank you, Susan. So I'm Susan, or Sue Powers for this purposes, so we don't get confused. I've been at Clarkson for my entire academic career, and I have worked myself up from assistant professor to my current position. And I found being at one place really works if you sort of move around in your roles and responsibilities. So I've had a variety of different roles, including administrative roles, that have really helped me be happy where I am and have given me a lot of learning opportunities. That's one thing I think hopefully you'll learn from me, is that keep on learning. You always can learn more. Next. So I a little different, like compared to Bruce and some of the other people, in terms of like really transitioning throughout my career to follow what I am passionate about and using my education to really enable me to do that. When I first started, I taught groundwater and hazardous waste management. That was directly what I did for my PhD. It was an easy in. Just I took even class notes from my PhD experience. But then I had opportunities as I went. I had a mentor at Clarkson, Tom Tice, who got one of the first IGERT grants, which many of you don't know about, but it was a huge grant for interdisciplinary work. And I learned about industrial ecology because I had to teach it. And it was something I was really passionate about, and I still teach it now. So I think that was about 2000. So I still teach it. It looks very different today than it did then, but I still teach it. Another proposal opportunity for education brought me to develop a class of climate change, specifically for engineers. And now my current roles are helping me teach to a broader range of students environment and sustainability. Through all these years, I have done a lot of teaching, introduction design and capstone design classes. I bring projects into almost all of these courses have semester projects. And I've also done some special topics projects classes that aren't quite capstone classes, but they still use projects as a way to really educate students. Next. So my advice here is, first of all, seize opportunities when they arise. Your evolution, I think that you've seen from all of us who've been academic professors for a long time. And if you want to keep learning and evolve into new areas of research, I think teaching a class is a great opportunity to really, if you can teach it, you know it. So it really forces you to dive deep in a way that just writing a proposal doesn't. So I've used that opportunity a lot. Next. So I'm just going to show you two quick examples. I'm not going to belabor them that I've shared with AESP audiences in the past. I worked with students. This started with a student wanted to do this. But on campus, our mixture of engineering students and others designed a cold climate greenhouse. I'm in a cold climate, northern New York. But they really had to see how the systems and all the parts fit together, right? We usually have capstone design classes where the civil engineers do this and the electrical engineers do that. But when they had heating systems had to work with the civil engineering systems and how much heat do we need if we have this much insulation and what is the incoming sun radiation going to do to our heating load and how do we make sure that we have adequate water and clean water for growing plants, all of that fits together. So I'm a really, really big believer that we want our students to understand the interconnectedness and the interdependence of all these types of systems. Next. Okay. Very different type of project, and this is part of my role as the director of our Institute for Sustainable Environment. In addition to teaching typical, part of my administration is overseeing campus sustainability initiatives, and so that gives me a wealth of projects to bring into all sorts of different classes and co-curricular activities. But food waste is a big, important challenge, both on our campus and in our community. So using things like understanding wasted food, it's great mass balance opportunities, but also to come up with the management plans that have to meet the needs of all the different stakeholders. We often forget that the most important constraints of our solutions are not the technical constraints, but they're the people constraints. And these types of projects really get at that and make students learn that it's not just the engineering technologies that make up our sustainable future. Next. Oops, one more. There we go. So one of the things that I would challenge everybody to do is to really think about what are the learning outcomes we want from our classes. And that's been hinted from our previous two, or maybe all three speakers. But in the green box, the disciplinary competencies, right? We all know those. What is it? What is it about environmental engineering? Mass balances, energy balances, the biosystems. Those are all really, really important to our graduates. But I've been thinking a lot about sustainability competencies, and those especially in the black box and the systems thinking, the futures thinking. Our students' future is changing, right? What we can envision about the future is changing so rapidly. To get our students to think about what is that future going to look like for them, and how do I think about how I'm going to use that information today in any design decisions, because 10 years from now is going to look very different. How do I make sure that my designs are forward thinking? Jim said that great in his hockey analogy, right? We need to make sure that our students are futures thinkers. And then in the lower boxes, right, we know that they need to be critical thinkers, creativity, learning. So this is just a paper I follow and use a lot. We need to think about not just the disciplinary competencies, but all these other competencies as well, if we're really truly trying to graduate engineering professionals who will go on and help to make our future more sustainable. Next. So I think that you should reflect on what's most important to you. These are some of my values and something that I believe. But I do think that we need to always think about a little bit more than just the disciplinary competencies as we think about what we want to teach and how, not just what, but how we teach our students. Next. So I really define projects as the key to the educational experience. As I said, this could be in a capstone design project, but it does not have to be. All my classes have relevant real world problems, projects. They're always very data heavy because the data, I'm sorry, textbook writers, the data that you get in most textbooks is not like what data looks like in the real world. You have to go find the data. It's very messy. It's very dirty. You got to clean it up. You got to know what makes sense and what doesn't make sense. And that's a big part of the problem solving system. But ill-posed problems, right? They're not all nice and neat. Um, so we can do all sorts of stuff. Think about our stakeholders. We're not just designing for technology that is effective. It's got to be effective wherever it is going to go. And I think a lot of Jim's work, as he mentioned, with the sustainable development and clean water is a case point there. Okay, next. So advice. One of the reasons why I do this and I've been able to do this, it is a lot of work, but I've always aligned it strategically with other things you are doing. My teaching and my research and my service all overlap. These are not three separate things. These are the same thing, just in slightly tweaked versions, depending upon who the audience is and how I go about doing it. Make it fun. That's partly the message about passion. And I think it's really important to explore ways that you can use these types of educational opportunities to think about educational scholarship. How do I make this scholarly? And I've done that. You've heard a lot about textbooks here. I haven't written textbooks, but we've written a lot of curricula that gets published. You can do presentations, short courses. There's all sorts of ways to make your education scholarly and make sure that you make that count as part of your scholarship. I can always help with that. Okay, next. So there's lots of other pedagogical approaches. This is from the United Nations Sustainable Development Goals report. I just want to say I've mentioned the real world projects, but also almost all my classes spend like a week of classes, 2 or 3 days, depending upon the class, doing some really big role play activity, whether that be a climate negotiation or I don't know, that's the one that I do most often these days, but something to give them, what's it really like to have the hard conversations about the solutions. Um, and so there's always ways to get students to think a little more critically, a little more reflectively, and think about the future. And next. So just quickly, some final reflection. Students really like relevant real world problems, but they are not good at doing it. I often find by the time I get them as junior or senior, they have been taught, write it, put a box around the answer and make it really easy for somebody to grade it. But that is not what they need to do in order to be a really, truly thinking engineer. And so our job is to facilitate, guide, and enable to help them learn that process, not just the process to do a mass balance problem, but also the process to think about the whole system and how do we put these parts together? How do we approach an ill-posed problem? That's part of the process we need to teach as well. So I think making decisions to me, and this is part about what do you believe engineering is? I have this argument with my colleagues all the time. To me, engineering is making the critical decisions with the right technical and data backup to move the right or the best, never right, I shouldn't say that, the best solution forward in a way, something that can be implemented and can work in whatever situation is appropriate for that solution. It's not just about the technology. And so that's important. And that's all I have. Thank you.
Thank you, Sue. And for the audience, we have selected a question ahead of time. We'll start with that. And then you all should be able to send in your questions through chat, and we will be able to pick questions as they are coming in. So I invite at this moment to my colleague, Dr. Kim. You have a pre-selected question that you would like to ask.
Okay, thank you, Sanjay. So I'd like to start with the first question on behalf of junior faculty, especially those who want to be successful in teaching as well as research. So what strategies have you found most effective for balancing teaching responsibilities with research expectations, particularly in the early years and beyond? I see Jim, so maybe Jim can go first and followed by Sue.
I thought Sue had a good comment about passion. She was integrating her research with her teaching interest, and I thought that was a really good comment. And I think Bruce maybe had the comment about managing time, being prepared for the class. So I think this thing about there's finite time, you have teaching service and research expectations. At sometimes you're a very good teacher and you just need to put it down to devote some time to your research, and devoting that time to your research will make you a better teacher.
You and Sue?
Jim already said it. I don't need to repeat.
Okay, thank you.
We have one question in the chat. I'm going to pick it up. And this is from Fernanda Cruz Rios. And it says, thank you for the incredible advice. You all lived through difficult times and periods of high uncertainty where it was challenging to work with sustainability, justice, science in general. Now, here's the question. What had helped you through those hard times? And what advice would you give junior faculty navigating the current times?
I'm going to repeat Mr. Rogers' comment. Those of you that are old enough to remember Mr. Rogers, find your helpers. It's basically find those that you can work with, find those that are going to help you along and that'll support you so that you'll be successful.
Anybody else? James?
Just real quick, I just found students. I love students. I love being around students. They provide so much energy. And even when I got a proposal rejected, students always just lifted me up. And practitioners, students and practitioners.
Yeah, sorry about the little technical delay there. One thing I always tell the people with whom I work or anybody who asks is that their success is my success. And so if you concentrate on your students and your postdocs and people with whom you're working and you're helping enable them to have their success, this will be reflected in my success. And so we always have students and we always have that opportunity. So we can always look forward in a positive way.
So there's one more question in the chat. It says that, what do you think are the biggest current challenges in environmental engineering education? In other words, what concepts and skills do our students most need to understand that we are still as a community, struggling to teach them effectively? Yes, Sue?
Yeah, I'll repeat that I think that it's sometimes the things that we don't think about, that it is getting harder and harder to work in the world of a divisive population and to work with communities, right? Almost a lot of our projects end up being in communities and having to work in communities and understanding the people side of things is really for any engineers, but I think especially for civil and environmental engineers, just the basis of the nature of what so much of what we do. And that is a big challenge. And I think it's harder now, and because the internet and people think they know it all, and there's so much bad information out there that trying to really stick with the facts and convey them in a way that is respectful is really important. Those intrapersonal skills.
So I think there is a Q&A option in the Canvas in Zoom. So if people are trying to use chat option to send their questions, uh, please use Q&A option at the bottom of the Zoom to share your questions. And if there are no other panelists who are jumping on that question, I have one more question over here in the chat. Uh, it says, thank you for sharing all the good words that you have. I was wondering, what is the view on the teaching outside of class and to the general public? What are your thoughts on scientific communication? Susan?
I'll just jump in real quickly. I think a lot of us get great pleasure and again energy. So I have a lot of colleagues that are in the classroom, K to 12 education. We have a lot of colleagues, some might notice are on the webinar, that are very engaged, engaging with the practitioner community, engaging their students with the practitioner community. So I think we need to think beyond our college students of other people we can educate, and we can be writing op-eds as a university professor. You know, I always felt I'm a state employee. So it's okay for me to speak out on issues of the state to get an op-ed or a letter to the editor.
I would just add, some of our seniors are also a great audience. Most communities have, you know, all sorts of courses for our seniors. They want to learn, and boy, is it so nice to work with people who are engaged and participatory, and they have that life experience that they can interact with you in a different way than our college students or, you know, high school students. So don't forget about our seniors.
Mhm.
Yeah, I'll just add that education outside of the academia is I'm going to say, almost as important. I mean, find ways. I've done it through Girl Scouts. I've done it through Scouts BSA. Done it through just general high school summer programs. But being able to help both the next generation and others just understand complex scientific issues is extremely important. And we do need to counter all of the misinformation that's out there. So spending some time doing that, I think, is really beneficial.
Yami,
Yes,
you,
great panel summaries, and thank you all for the advice you've given. I think one of the key questions for some of us who are just starting are, what kind of teacher training did you receive in your first early years? And maybe to expand that a little bit, because sometimes people come in, you've had TA experience and you feel like, all right, I have some experience teaching. Maybe there's some things you can talk about in terms of like some things you can dispel, right? As someone who's maybe been a TA but has never actually taught a class. So what training did you receive in your early years apart from just going out and doing it? And what kind of skills, what kind of things can you dispel from, being a TA that's very different from actually teaching the course?
I would venture that when us older giants, and I'm probably the youngest amongst us, graduated, there was absolutely no such thing as training for young faculty. It was just not part. We were trained how to do research, and that's what it was all about. And you sort of basically whatever model your favorite instructor had was sort of the model that you took. What I found is that I didn't get any training then, and I wish that I had some training. But it's even if you have training right when you get started, and I would strongly suggest, so like the Exceed, am I saying that right? The ASCE is a great training model. We've had several of faculty do that. There are others like that. But it's got to keep on, right? Everything changes. The first time I had to teach with a learning platform, right? How do you organize a Moodle course so that makes sense, right? None of us had done that before. It's just the tools and the techniques and the expectations are forever changing. So it's just like everything else we do is it's like on the job training all the time if you want to keep up with just I am way behind on AI. I will admit to that, but I recognize that it's something that I should probably spend some time doing.
But the only training I had was that I was actually teaching intro. I was struggling teaching intro. We had a highway traffic safety program, which were actually the faculty involved in that were educators. I went to a couple of them and said, hey, I need some help. Can you come to my class? Can you give me some feedback? And basically that's what they did. So they came to my class. We talked about it afterwards. They wrote up some stuff. They came back later, after I tried to implement. I and then the only other training I had was the Lilly Teaching Fellowship. And that's Carl Smith was leading that. So it's where I learned some of the active learning techniques. So if there isn't any, there isn't anything, again, find the helpers, okay? Find those that are willing to come into the classroom, work with you, and improve on your teaching. And
Jim, I believe you had something you wanted to say?
Nothing to add, and I see Bruce's mic is open, so.
Yeah, I'll just say one thing. As a student, I had a lot of really great professors, and I had a few really bad ones. I learned more from the bad ones. The saying, it's an important thing, addition by subtraction, right? Well, you see what didn't work, don't ever do it. And make sure you do exactly the opposite of that. I can really learn very well from bad examples, and I've done that over my career.
Now, Bruce, I think that we might have missed a hand from you when we were talking about emerging issues, things, competencies that we thought students should have. Did you have something
Yeah.
you wanted to add there?
Yeah, I'll just add one thing, and this is a bit like what Sue said. The students are really good at answering questions when we, lay it out for them. They're not very good at coming up with the questions. And so if we really wanted to help students, develop themselves, we would give them the opportunity to actually do, come up with the questions. And I always tell the students in my class, particularly undergraduate, because if you really want to study for the exam, what you do is you pretend you're the professor and you write the exam questions, and then you solve them. Maybe in a team. I don't think anybody does this. They should. Oh, but but this is really a weak link. It's easy to answer questions when it's laid out, but it's hard to ask the right ones.
So we are hitting 4 o'clock mark. We'll continue taking some questions, but we do not have a big buffer after 4 p.m. Central Time. So I think there is a question to be taken. Dan, are you taking that next question?
Okay, there's a question from Kate Newhart. How do you address missing prerequisite knowledge? I've noticed that students' skill sets are shifting coming out of secondary and early college. Can anyone answer this question? It's a tricky one. I can tell from Bruce.
Well, prerequisites. Students, someone, maybe Sue said it, the students, they forget the equations, they forget a lot of stuff. So having had those prerequisites isn't really any proof of anything. And so whether the students had the prerequisites or not, the key is they need to inform themselves. And I often give the students, in advance or at the beginning of the class, things that they should know coming in. And if they know them, great. If they don't know them, they could figure out how to get them, and it doesn't matter on their prerequisites or not. They should take responsibility for coming in with basic knowledge.
Jim?
I mean, undergraduates have their prerequisites for class, and I think most of us follow them. So I think, engineering is about lifelong learning. I think we should expect our graduate students to be able to learn things on their own. Maybe we have to help facilitate them what they need to. This is an appropriate resource that you can use to come up to speed, in biology when you're taking my Bruce class kind of thing. So I think this is lifelong learning. So students need to be able to learn on their own.
That's good.
I think, though, that it's a little more complicated than that because especially the students who have been, they took physics in high school, but it was coded physics and they really didn't learn anything and they don't know calculus. And I will admit that I have been, for some of my undergraduate classes, dumbing down the reading assignments and suggesting that they watch videos.
Mm.
And which makes me really sad because I believe they need to be able to learn to read. But I also think that they need to have the material in my class needs to be accessible. And so if they get that by watching videos instead of reading, is that wrong? I want them to read. I think they would get a deeper sense of the material if they would read. But they won't get anything if all I do is assign them reading and they don't do it. Whereas if I assign them videos and they do it, at least they will, hopefully come up with some of that knowledge that I expect them to have coming into class. So it's it's a very socially cultural challenge. It's people don't want to read. They don't have math skills like we expect them to. One thing I would say is you should definitely be in contact with the people who teach the first year, chemistry, calculus, physics, biology, and see what they're finding and maybe some cross-campus conversations about the most important learning outcomes from those classes. Maybe they don't need to know everything, but what do you really need to have them know might help. It is a whole campus conversation that's needed about this question. It's a very good question.
So I
And
want to follow up on that.
yeah, I was going to go ahead, Stephanie.
I feel like, and I think it was even you earlier that mentioned IGERT programs and sort of through the 2000s moving into today, everything emphasizing being interdisciplinary. And we're sort of putting that as a buzzword. We're trying to make that central in our education method. How are you actually seeing that in your classes? And maybe this is also kind of a Bruce question. If you've taught the same class for so many years, are you changing that course to adapt with whatever the new buzzword is and the new models that we have for teaching? Or are you sort of saying, okay, throw away the old one, let's create the new course that's the new big thing?
I think it's just continuing to evolve as times change. Boy, I'll tell you, I'm having a hell of a time teaching climate change this semester with every week it's something new. I'll stop there. But things change and we have to change. And, when it becomes a policy class instead of a science class, well, so be it.
Yeah, and one of the things we have to keep in mind about our field, this is very important in this context, is that a lot of the technologies that we help develop and they get out in the field, they stick around for like 50 years. So it's not like the world changes and suddenly all of our technologies change. No, activated sludge, primary sedimentation, that's going to be there. It's there now. It's going to be there for a long time. So the students must know all this because they're going to have to deal with it. But and then there are newer things too. So, when I'm teaching an undergraduate course, I have to focus mostly on the conventional things because that's what's out there and that's what these students need. But I bring in some new things every time I teach it, depending on what's actually been developing, recently.
James, do you have something? I believe you were nodding, and if you have something to
Oh,
add.
no, I was just I was agreeing with what Bruce was saying.
So I'm going to jump on what Sue said about reading assignments and also assigning videos, which are parallel, giving same kind of context, for students to have a base for the classes. And prereq question that was asked previously. Uh, Many of us teach classes that are taken by civil engineering majors as well as environment engineering majors. And when it comes to prereq, expectations are kind of same for introduction to environment engineering class. But I have seen in my years of experience that students who are pursuing environment engineering major, they come with very solid chemistry background and they are able to do a little bit higher level calculations. But civil engineering major, I believe policymakers, whoever they are, somehow they end up choosing chemistry class that just doesn't give them a very solid background for CE students to be successful, specifically in environment engineering classes. How much time do you spend if you are teaching introduction to environment engineering class on reviewing the chemistry to these students? Or how do you deal with this kind of situation?
Well, I'll just say, I don't know if Susan Maston has a comment on this for her book, but in my first environmental engineering class book, I've tried to put a lot of examples in for chemistry and biology and such, and students can go in and just practice a lot, just more repetitive practice or background material that maybe is not covered as much in depth in the classroom.
And what I've tried to do is when I taught intro and I tried to do it in principles, is to teach it in context so that students understood why they're learning chemistry or why they need to know biology, not just it was this abstract concept out there that they have to apply it. And if they do, it works this way or if it does. So trying to teach them in context. And I've tried to do the same thing when I teach water and wastewater. I have to do the same thing. I have to bring back the chemistry. I have to redo, reactor theory. But again, trying to teach it in context so that they understand why they need to know it and how to apply it.
Yep, context.
This transitions us very nicely to a question that we have from Jinyu. I'm going to sort of paraphrase. She does give a shout out. So, Jim, she uses your textbook. So you've got at least one class of students that are still buying it. For this question, how are you encouraging students to really move beyond right or wrong numerical answers for exams? A lot of students are really centralizing their thoughts on, can I do the math? Can I do the math? And maybe you're stepping back from that understanding of context. How are you setting up class policies or incentivizing students to not just try and rote memorize, do the practice exam until they get it right, and really think about those deeper critical thoughts?
I
I'll
throw
take
out
the first.
exam-
I can take the first cut. Well, I think it's important students do some repetitive things, to understand BOD, for example. I don't think BOD is. It seems very simple, but I don't think it's simple. I don't think it's an easy thing to teach. So there's some repetitive things where you're using some kind of formula, but you have to understand what all those terms mean. So I think when you're assessing students, it's like, okay, you can assess on a plug and chug kind of equation where they have the equation, or you can assess them more where you present the problem and maybe you don't say y equals this. So you kind of give them a real problem, and then they have to decipher to really understand the meanings of those different inputs into an equation.
So I don't see anyone continuing this question. I have another question for the panel, and I'll try to keep it short. How have you dealt with situations where students sitting in the classroom and they tell you that my learning style, since we are dealing with the newer generation of students, they are more aware of their learning styles, and we want them to be aware of their learning style, whatever works best for them. But teaching a class full of mixed students, how do you accommodate different learning styles? And a student may say that, great, but when it comes to complicated spreadsheet calculations versus PowerPoint, that doesn't work for me. We all have limitations dealing with time and core content that we need to cover. At the same time, we are trying to accommodate all the students and their learning styles. What kind of challenges you have faced and how you were able to accommodate these different competing priorities?
Okay, I'll start here. First of all, if I ever had a student come to me and said, "Oh, my learning style is this, and your course is not doing it," or I would be amazing. Students, if they're aware of their learning styles, this is a tremendously positive thing. And if they can come to me with it, I think that'd be great. I've never had that happen. So but what I try to do in my classes is have different ways for the students to learn. We have the lectures, that's with 50 students in the class, you can only do so much. But then there's homework assignments. I encourage students to form, teams to work together on things. And they can always come and if I have office hours, they can come and make appointments with me. So I, there are different options available naturally is the way the course is organized on it, if they're aware of what, they learn best. And I just think, I don't think students really know, but maybe I'm wrong. What do others think about that?
I'm going to build on what Sue said about videos versus reading. I mean, where there are other materials available, finding some of those materials, embedding some of that materials, or having that material. It's kind of nice actually having recorded lectures from during COVID that I could edit and kind of clean up. Students could go back, and I mean, the material didn't change that much from year to year that they couldn't come back. And basically, I would try and organize the material so that they could go back and relearn it, or they could use material online. Try to do visual so that there's visual aspects. I've tried to do more even in class where there's more hands-on. So just getting them out so that they can see it, feel it, touch it, that it's not just reading.
So I would add, and this also goes into the next question in the chat about the student habits and attitudes that we've noticed. Certainly all of these things address sort of that question as well. We regularly record our lectures and make them available. Especially important, I think, for our students for whom English is not their native language. so that they might not get it, right? That the auditory, rapidly the first time is not there. So that's a tool that they can use. Sometimes they do it slowly. One of the challenges I found in terms of change in attitudes, a lot of our students now don't take notes. And so, which I think is horrible, right? Because the act of taking notes is one way to just the neuro, how your brain works, is really, really important. And so the notes are, the PowerPoint's on Moodle, there's recorded lecture. I don't need to take notes. And so I think that's something that I wish that I could convey better. But I do think every class, when you think about what do you do to keep them engaged and give them different opportunities, working with their neighbor on something, I think Susan mentioned that, to get started so they have to critically think during the class period is really, really important, especially if they're not taking notes. They're still doing something. So things are changing rapidly. And I think we just have to keep evaluating for ourselves what seems to be working, talk to your colleagues, figure out what they're doing to adjust to these changing times, and just do lots of different things. I think the classes that are just straight lecture for 50 or 75 minutes are no longer what cuts it in today's world.
Stephanie?
Yes. Thank you to all of our panelists. We are going to sort of start wrapping up now, since we have run over time. All of these people have so much experience for us to learn from. We can't answer all of the questions here. That said, all of them are accessible, so you are welcome to email anyone and reach out, and I'm sure that they will be more than happy to answer questions. There are a couple of remaining comments and questions in the Q&A. So particularly on the note of AI, the Education Committee has done some previous webinars. So you can always go back in YouTube and watch some of those previous recordings as a way to get some of those thoughts and conversations started. That is also a good reminder that this webinar is being recorded. So if there's something you missed, if you were like, wait, I want to get that quote down, we'll have it up in the next couple of weeks on the AEESP YouTube channel, so you can rewatch it there. We also have a couple of shameless plugs to give for some of the education training materials that were mentioned here. So one of them is our partners with ASCE for civil engineering do run the Exceed seminar series. That is going to be hosted at Carnegie Mellon University this upcoming summer. And so the applications are due relatively soon. You can simply Google ASCE and then Exceed, EXCEED, and you'll find that application. Additionally, some of the other education engineering societies were mentioned in the seminar, such as ASEE, too many similar acronyms. You are welcome to join us this summer in Charlotte, North Carolina for ASEE. If you're interested in seeing some presentations from across engineering, not just environmental engineering, and how we are innovating as engineering educators across the platform. And of course, AEESP has a fantastic array of committees and communities of practice that you can join. Simply go to AEESP website and you can find contact information for any of those. Now, final thoughts from Sanjay, our fearless leader of the Education Committee.
Thank you, Stephanie. I really appreciate all these announcements. One more to add to that list. ASCE is going to have a virtual roundtable discussion next week. The flyer is already out. I will put it again. I will send it through AEESP server, but it's from ASCE, just in case you are interested, including ASCE 555 vision, preparing workforce for the future, and including bringing keen EM-based mindset into your courses. So we are going to have that discussion next week. With that, I want to thank you to all the panelists who took time out, shared the pearls of the wisdom that they have acquired over their entire career, and shared the tips with us. Some of the advice, if they were given to me when I was first starting as fresh out of my PhD, would have changed my life right away. But I learned things hard way. Many of us did. So thank you very much for everything that you shared with us. Audience, thank you very much for lively session, for all the questions. We tried to take all the questions. Sorry if your question was not picked up because we are running out of time. And thank you to Stephanie for running the technical side of this webinar. Taeyang, thank you for partnership with SOS Community of Practice. So at this moment, I would like to conclude this webinar with a heartfelt thank you note to my panelists and all the audience.